There's a side of the moon that no human being saw for the first 4.5 billion years of its existence, and almost everything you've heard about it is wrong. It's called the dark side of the moon, but here's the first twist. It's not dark. It gets exactly as much sunlight as the side you see every night. In fact, because it never faces the Earth, it's never blocked by Earth's shadow during a lunar eclipse. So it actually receives slightly more total sunlight than the side we call the bright side. And here's the second twist. The side we see from Earth with all those dark patches, that's actually the darker side. The far side is brighter. So why do we never see the other side? The answer is a gravitational phenomenon called tidal locking. The moon takes 27.3 days to orbit the Earth, and it also takes exactly 27.3 days to rotate once around its own axis. Those two numbers match perfectly, which means the same hemisphere always faces us. It's not a coincidence. Earth's gravity gradually slowed the moon's rotation over billions and billions of years until it synchronized with its orbit. It's actually common in the solar system. Pluto's moon, Charon, is tidally locked, and so are most of the large moons of Jupiter and Saturn. Now, the moon does wobble slightly as it orbits, a phenomenon called libration. This lets us peek around the edges and see about 59% of the total surface over time. But the remaining 41% was completely hidden from every human who ever lived until 1959. October 7th, 1959, at the height of the Cold War space race, the Soviet probe Luna 3 swung around the moon and snapped 29 photographs of the far side. 18 of them were unstable. They were grainy, blurry, and absolutely revolutionary. The first time in history that any human had seen what was on the other side. 9 years later, in December 1968, the Apollo 8 astronauts became the first humans to see it with their own eyes, and what they saw shocked them. It looked nothing like the moon they knew. The near side of the moon, the face we know, is covered in large, dark, flat plains called Maria, Latin for seas. These are ancient lava flows from billions of years ago, covering about 35% of the surface. Early astronomers actually thought they were oceans. But the far side, almost none, just 1% is covered in Maria. Instead, it's absolutely battered with craters, thousands upon thousands of impact scars, like completely different planets. Scientists have been asking this question for decades. Why does the far side look so radically different? The leading theory goes back to the moon's violent birth about 4.5 billion years ago. A Mars-sized body slammed into the young Earth, blasting debris into orbit that formed the moon. In those early days, the moon was tidally locked while still partially molten, and the near side faced a superheated Earth radiating enormous amount of thermal energy. That extra heat kept the near side's crust thinner and its interior warmer for longer, allowing volcanic lava to erupt and flood the surface, creating the dark Maria we see today. The far side facing cold space cooled faster and developed a crust up to twice as thick, too thick for lava to break through. Hidden on the far side is one of the most weirdest features in the entire solar system, the South Pole. It's an impact crater 2,500 kilometers wide and up to 8 kilometers deep. In 2024, China's Chang'e 6 mission landed inside the basin and brought back the first ever rock samples from the far side of the moon. Nearly 2 kilograms of lunar soil. Now here's where the name dark side does become real, just not the way most people think. While the far side as a whole gets plenty of sunlight, there are deep craters near the moon's poles where sunlight has never reached, not once in billions of years. These permanently shadowed craters are some of the coldest places in the entire solar system, dropping to minus 248 degrees Celsius. Scientists call them cold traps, and there's strong evidence they contain water ice, frozen oceans in eternal darkness. And the far side holds another kind of darkness, radio silence, because it always faces away from Earth, and the far side is shielded from all of our planet's radio noise, television, cell towers, satellites, Wi-Fi, everything. It's the quietest place in the solar system for radio waves. That makes it the ideal location for future radio telescopes that could listen for signals from the earliest moments of our universe, signals that Earth's own noise drowns out. The dark side of the moon was never really dark. It was unknown, and for 4.5 billion years it kept its secret perfectly. If this blew your mind, hit subscribe and turn on notifications. We've got more space stories that will change how you see the universe. Drop a comment. Did you know that the dark side was actually brighter? I bet most people didn't. See you in the next one.